Do what? For your grade? Yeah. Somebody did. Said a 25. All right. Today we're going to talk about LCM. On Thursday, if you have a smartphone, you need to bring it to class. We're going to look at an app that will help you with some of the things we're doing right now. So on Thursday, we don't have class tomorrow because it's chapel day. It's the first week of the 6 weeks, so we skip first hour. But on Thursday, bring your smartphone if you have one. If you don't have one, it's not that big of a deal. But if you have one, bring it to class, and we're going to download an app that will help you with some of the stuff that we're doing today, or these couple of days. Today we're going to talk about 3.5, which is a least common multiple, which is the LCM. The LCM is probably a little bit more, I don't know if important is the word, but it's probably used a little bit more than the GCF. The LCM is also called the least common denominator. When we start talking about fractions in the next section or the next chapter, we're going to talk about the LCD, which is the least common denominator, which is the same thing as the LCM. Okay? So, obviously, when you're adding and subtracting fractions, you've got to have the common denominator. Therefore, you've got to know how to do LCM. Okay? LCM is similar to what we did yesterday in the sense of, there's a shortcut. The shortcut is using prime factorization, and then we do prime factorization a certain way with the numbers we get. What I want to look at first, though, is what is a multiple. Okay? What is a multiple, Jonah? Okay, the answer to certain numbers. I think I know what you're trying to say. Yeah, it's not the factors. Okay, let's put it this way. I think you're on the right track, but let's put it this way. Multiples is counting by a certain number. Okay? For example, if I'm going to count by 4, okay, the very first one is 0. Okay? That's the first multiple of every single number. Okay, is 0. But more realistically, when you count by 4, you have 4, 8, 12, 16, 20, 24, 28, 32, 36, and it goes on forever. Okay, you could literally sit there and count by 4s your entire life and never stop. Okay, now, obviously, you're going to get some very large numbers, and it's going to take you a long time to say the numbers each time, but if you were counting by any number, it never ends. Okay, so that's the difference between a multiple. Now, basically what you have is that's 4 times 0, that's 4 times 1, that's 4 times 2, 4 times 3, 4 times 4, 4 times 5, and so on. Okay? So that's taking a number and basically counting by it. Okay? So, if we have 2 numbers, for example, if we were looking at 22, and I was counting by by 22s. Your first one is 0. Then you'd have 22, 44, 66, 88. Let's see, next one's going to be 110, 132, and it keeps going. Okay? So, if we happen to be looking for the LCM of 4 and 22, okay, if we were looking for the LCM of 4, the least common multiple of 4 and 22, okay, well, as I look at the ones for 22, does 4 go into 22? No. Okay, so I know it can't be 22. Does 4 go into 44? Yes. So, the LCM of 4 and 22 is 44. Okay, just like I gave you a note yesterday, I'm going to give you a little note today. The LCM will never be smaller than the largest number you are comparing. Okay, so if I'm comparing 4 and 22, the LCM can't be smaller than 22. Okay, now, if we really wanted to get technical, the least common multiple of every single number is 0. But does that help us with fractions and other things? No, we can't put a 0 on the bottom of a fraction. So what they're basically looking at, why we need to know this, one of the many reasons, is if I was adding 1/4 plus 3/22. If I was adding those two numbers, I can't add them unless I have a least common multiple. So I'd have to change the denominators on the bottom of the fraction to the least common multiple. Okay, we'll talk more about that obviously later on when we get into the fractions part, but we have to, for our purposes today, we need to know that. All right, now, do what? All right. Now, when you look at LCMs, for example, if I was giving you the LCM of 16 and 6, okay, the ones that you're going to be dealing with in this section are not going to be that large of a number, okay? So it would realistically not be hard to count by the number and get to the LCM. For example, if I was counting by 6s, I'm going to start with 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Okay, if I was counting by 16s, that's a little harder, obviously, because the 6s is in your multiplication tables. Okay, but 16 is a little bit more difficult, but you still, it's just 16, 32, 48, 64, 80. Okay, well, we've already run into one that's common, 48. Is that the smallest one that's common? Yes. Okay, so the LCM of 16 and 6 is equal to 48. Now, I'm going to show you the shortcut way, because eventually, and not necessarily in this 6th grade year, but in 7th grade, you're going to have LCMs that are up into the 2, 3, 400s. Okay, and so obviously if we were going to count by 6s into the 2, 3, or the 400s, that would take us a while. Okay, so there's got to be a shortcut, and the shortcut is to use prime factorization. Okay, so I'm going to take both numbers, and I'm going to prime factor 6 and 16. Okay, so if I prime factor 6, that's 2 times 3. If I'm going to prime factor 16, okay, that's 2 times 2 times 2 times 2. Now, with LCM, list the prime factorization using exponents when possible. Okay? Using exponents when possible. Now, so my prime factorization of 6 is 2 times 3. Is there any exponents that we can use there? In other words, did we use 2 more than once, or did we use 3 more than once? No. So I can't have any exponents on this one. The other one, 2 times 2 times 2 times 2, how would I express it as its prime factorization with exponents? Staley. 2 to the 4th power. That is correct. Okay, now, here's the part that is different from yesterday. Okay, yesterday we were grabbing numbers that were alike in each prime factorization. Okay, today we're going to use the highest power of each prime factor. Okay, so first of all, what I want to do then is I want to first prime factor the numbers. Second, I want to list the prime factors that were used. Okay, that's step 2. Okay, so I'm going to look at this and that, and I'm going to list the prime factors that were used. Okay, now I don't repeat the prime factors. In other words, what are the prime numbers that were used in either of the prime factorizations? What's one of them, Jonah? 2. So I'm going to list 2. I'm not going to list it twice. I'm just going to list it once because 2 was used. Okay? What else was used? 3. Is there any other prime numbers that were used in those prime factorizations? No. Okay? So that's step 2. I'm going to put a little multiplication sign in between the 2 numbers. Okay? We're not done yet. Step 3, okay, step 3 is find the greatest power of each of the prime factors and use it. Okay, so my prime factors, once again, were 2 times 3. Okay, now, the greatest exponent, or the largest exponent with a 2 is what? 4. What is the exponent with this 2? No. What? It would be 1, because how many 2's do I have? 1, 2. So the exponent here is 1. We just don't put it. Okay? What's the greatest power of the 2? 4. So I use the 4. What is the greatest power of the 3? 1. So I use it 1 time. Okay? Now, once you've done that, step 4 is to multiply the prime factorization in step 3. So I'm going to take that and I'm going to go 2 times 2 times 2 times 2 times 3. 2 times 2 is 4 times 2 times 2 times 3. 4 times 2 is 8 times 2 times 3. 8 times 2, 16 times 3. 16 times 3, 48. Okay? So the LCM, just like we proved a while ago by counting, is 48. Okay? Now, before we ask any questions, I want to do another one similar to that without writing all the steps down. Okay? So I'm going to find the LCM of 28 and 42. Okay, the LCM of 28 and 42. All right, so prime factor both of them. I'm doing it in both ways still, inverted division factor tree to prime factors so everybody understands it. 2, 14, 2, 7. So 2 to the second power times 7. 42, 6 times 7 is 6 prime. Is 7 prime? Yes. So now I've got to factor 6. That would be 2 times 3. Those are both prime. Okay? Now, so the prime factorization of 43 is 2 times 3 times 7. Okay? So now, step 2 was to do what? Okay, list the prime factors that were used. Okay, so what is one of the prime factors that's used in either of these prime factorizations? 2. What's another one? What's another one? 3. Okay, see, some of you right there thought back to last night. They don't have to be shared by both of them. They just have to be used. Is 11 used in this? Is 5 used in this? Okay, so we don't obviously list those. We list the ones that were used. 2, 3, and 7 were used. Okay, we do not list the 2 twice because it's used in both of them. We don't list the 7 twice because it's used in both of them. We only list it 1 time for as many times as it's used in this step. Okay? Third step. Third step was to find the greatest exponent or the greatest power of each prime factor. Okay? So, as we look at this, I have a 2 to the second and a 2 to the first. Which is greater? 2 to the second power. So I use it to the second power. Okay? I can't take both of them. I can't take the 2 to the second and the 2 to the first and put them together. Can't do that. Okay? You can only take from one or the other. It's like if I had a handful of money and I had 2 $5 bills in this hand, I had 1 $5 bill in this hand, but you can only take out of one hand, which one are you going to take? The 2 $5 bills, right? You're not going to take the 1 $5 bill unless you're, a nice person, you want to leave me with more money. Okay? So we can only take the highest one. Okay? You can't take both of them. All right, now, this is the one that gets confusing for people sometimes, okay? I have 7 to the first and 7 to the first. So what's the highest power? 7 to the first, okay? If they're both the same, then does it matter which one I take out of each one of the hands? No. If I've got a $5 bill here and a $5 bill here, it doesn't matter which one I take. I can only take one of them, okay? So I take the 1. And you don't have to put the 1 above, the little exponent 1. I'm just doing that to make sure everybody understands that we're taking it one time. Okay, then we have 3 to the first and no 3. So what's the highest power? 1. So I take it one time. Okay, now we multiply it out. 2 times 2 times 7 times 3. 2 times 2 is 4, times 7 times 3. 4 times 7 is 28, times 3. 28 times 3 would be what? $84. Remember, use your distributive property. You can do that in your head. 3 times 20 plus 3 times 8. What's 20 plus 8? 28, right? Okay, what's 3 times 20? 60. What's 3 times 8? 3 times 8? 24. 24 plus 60 is the 84. Okay? So that's how you can do that stuff in your head where you don't have to always do it on paper. Okay? So 84 is the LCM. Okay? Like I stated, the ones that you're going to be dealing with right now are not that large. Okay? They're really not. But let me see real quick here. Chapter 5, I believe. Bear with me one second. I'm going to try to... Okay, I'll give you a good example. This is one out of the 7th grade book. Okay, all of you are in 6th grade. Hopefully you get to go to 7th grade next year. Okay, but this is one out of the 7th grade book. You have 34 and 52. Okay, now this is one of those that you really need to know a shortcut, because if you don't, then you're going to spend a long time doing this one. Okay, so we do the shortcut. Shortcut, we prime factor. We prime factor 34 is 2 times 17. We prime factor 52. That'd be 2, 26, 2, 13. So 2 to the second times 13. Now, the prime numbers that are used, 2, 13, and 17. Those are the prime factors that are used in either of the prime factorizations. Okay? What's the greatest exponent for 2? 2 to the second power. What's the greatest exponent for 13? 1. So 13 to the first power. What's the greatest one of 17? 1. So now I have 2 times 13, which is 26. Nope. We have 2 times 2 times 13 times 17. Okay, so it's 2 times 2, which is 4, times 13 times 17. 4 times 13, 52, times 17. 52 times 17, 884. Okay, that's the least common multiple of those two numbers. Okay, so obviously, if we had to sit there and count by 34, okay, 34, 68, 102, 136, you got to do that all the way up to 884, okay? Now, what a lot of people will do is they'll say, okay, well, I'll just take, 52 times, I'll just take the two denominators times themselves, and that gives me a common multiple. It does, but then you're going to have issues of how far you have to reduce the fraction, okay? A lot of people just, they'll see 1 over 20 and, let's say, 3 over 60, okay? And they'll just say, oh, I'll just take 20 times 60. That's a common multiple. Well, yeah, it is. Okay, but if you take 20 times 60, that's going to be 1,200 on each fraction. Okay? When the actual common denominator to 20 and 60 is 60. Okay, so you can see that you want to know the least common multiple, which is also the same thing as the least common denominator. Okay, you want to be able to see that, you want to be able to figure that to save yourself work when you get to the fraction part of it. Okay? All right, I'm going to give you one I want you to try on your own. All right, let's see here. I want you to find the LCM of 12 and 20. Okay, find the LCM of 12 and 20. I'll give you about 2 minutes. All right. 12 and 20. If we prime factor 12, that would be 2 and 6, 2 and 3. So 2 to the second times 3. If I prime factor 20, that would be 2 and 10, 2 and 5. So that's 2 to the second, 2 to the second times 5. Now, remember, you can use the factor tree for 12. That's 4 times 3, 2 times 2. Okay, you can use the factor tree for 20. 4 times 5, 2 times 2. Okay, you're still going to come up with the same prime factorization. I don't care which one of those you use. Okay, now, what are the prime numbers that are used in this problem? 2, what else? 3, and 5. So 2, 3, and 5 are the prime factors that are used. Now I have to find out which is the greatest power of each one. Okay? So I have 2 to the second, 2 to the second. So I use it what? 2 to the second. Greatest power. I have 3 to the first, no 3. So I use it what? Once. I have 5 to the first, no 5. One time. So I say 2 to the second, which is 4, times 3 times 5. 4 times 3 is 12 times 5. 60. So the LCM is equal to 60. Okay? Now, your work for tonight. 3.5. 3.5, 1 through 4, and 10 through 22. That is your homework. Now remember, tomorrow's chapel day, but don't ever depend on that. Okay, here's why. A speaker could come, or a speaker could have car trouble, and we don't end up having chapel. So if you don't end up having chapel and we have class, it is due. So do it tonight. Don't put it off and do it, try to do it tomorrow, because, hey, you don't need to have homework on Wednesday, so make sure you get it done tonight. On Thursday, bring your smartphones to class. I'm going to show you an app that you can download that will help you with some things, and we will do more review over GCF and LCM. Okay, I know a lot of you did miss quite a few problems. We're going to continue to go over it till we get it, okay? You may go.